Next, let me consider the case where we have one qualitative variable with more than two categories and one quantitative variable, and we want to study their association. And we use ANOVA, analysis of variance, and for that we calculate F statistics. Let me consider here age and major. Now age is a quantitative variable and major is a qualitative variable with three categories: business, first category; IT, second category; and political science, the third category. Now here we calculate the F statistic. Here that F statistic is equal to mean squares between divided by mean squares within, and mean squares within and mean squares between is nothing but sum of squares between divided by degrees of freedom between, sum of squares within divided by degrees of freedom within. And therefore, in order to calculate the F statistic, we start by calculating the MSB, mean square between, and for that I need sum of square between and degrees of freedom between, and then compute the mean square within, and for that I need sum of squares within and degrees of freedom within. Okay, let me start with degrees of freedom between and degrees of freedom. As you can see, the degrees of freedom between is equal to n minus k. N is the number of observations, which is 5 here. And k is the number of categories in a qualitative variable, which is 3. 5 minus 3 is 2. The degrees of freedom within is k minus 1, minus 1, 3 minus 1 is 2. Okay, next let's calculate sum of squares between. And sum of squares between is nothing but the sum of xj bar minus x bar squared. X bar is the mean of the quantitative variable in each category. For example, the average of age in business among business students, the average of age among IT students, and the average of age among political science students. J is taking value from 1 to 3 is x1 bar minus x bar, x2 bar minus x bar square, x3 bar minus x bar square. X bar is the total or grand average. Okay, therefore I need the total grand average. The average age is, I just calculate the average age of all 5 students. The average age among business students, that's the average of 17, 25, and 19, it is 20.3. The average age x2 bar, the average age among IT students, since we have only one IT student, this is 26. The average age of political science students, since we have only one, this is 18. And the grand average or the total average is the average of all observations in the age. We get that the sum of squares between is 20.3 minus 21 square, 26 minus 21 square, 18 minus 21 square. A little bit of calculation and I get 34.49 for the sum of squares between. Now for the sum of the squares within, it's a little bit complicated because I have double sums here. First sum is for groups, for the 3 categories: first category, second and third category. The second sum is for the individuals within each group. This one takes values from 1 to nj. Nj means the number of students in the first group, the number of students in the second group, the number of students in the third group. That is the sum of xi minus x1 bar, because x1 bar is the average among business students square, plus sum of xi minus x2 bar square. x2 bar is the average of age among IT students, and xi minus x3 bar, the 3 bar is the mean of age among political science students. Remember that, guys, that in the first sum here, xi is x1, x2, and x3 are the age of the 3 business students. Here we have only one IT student. X1 is the age of that only IT student, and X1 here is the age of that only one political science student. Now let me simplify this sum and this sum and this sum separately. Well, the first sum is for business students. Therefore, for xi I have 3 values. First, 17 minus 20.3 square plus 25 minus 28.3 square, and so on. So calculating this, I get 34.76. For IT students, I have only one student, 26.26. The average is also 26. The square is 0. The same is applied for political science students, it's 0. Therefore, the sum of the squares within is equal to the sum of this, and this, which is 34.76 plus 0, which is 34.6. Now, going back, you see that I needed the sum of squares between, degrees of freedom between, for mean squares between, mean squares within. I needed some square within, the degrees of freedom within, and I calculated all those. And let me put them together in order to calculate mean square between is sum square between divided by degrees of freedom between is 34 by 49 divided by 2 is 17.2545, and mean squares within is the same way, it's 17. Hence, if statistic, is the mean squares between divided by mean squares within, and inserting the values, I get 0.9. Now, I use an online calculator in order to find the corresponding p-value for this statistic, and that's nothing but this. I put 0.9, the f value, degrees of freedom for numerator, which is 2, degrees of freedom between, degrees of freedom within, which is also 2, and I just calculate the corresponding p-value for these entries, and that is 0.502, and I come back and write here that the p-value is 0.5, which is bigger than 0.1, hence there is no significant association.